We're looking at some additional examples of solving matrices. In this example, we're going to start again with a system of linear equations of two variables. Note that this is an augmented matrix. All right, so I should have this vertical line here. To the left of the vertical line are the coefficients, right? So this is a 2 by 2. All right, so we have two equations, two variables on the right-hand side. That's the right-hand side of the equal sign in terms of the equations. All right, so recall what we're trying to accomplish. We're trying to write this in row reduced form. We begin by wanting this first entry to become a 1. And in this case, I do have a 1 in the second entry, the first column, right? So I can implement that first operation to where we can interchange or switch any two rows. I'm going to do that here. So I'm going to switch row 1 with row 2. I'm just going to flip it. I'm going to put that 1, 4, 6 as the first row, 3, 7, 2 in the second row. All right, so now I've got my 1. I've got my leading 1. I've got that pivot. Now I want everything else in that first column to become 0. Okay, I make this become 0 by adding the additive inverse. And that is accomplished by adding the additive inverse times row 1. The additive inverse is a -3. I'm going to multiply that row 1, the row with the pivot, that leading 1, times the -3. Okay, over here to the side. All right, what are we doing? We're taking row 2 minus 3 times row 1, which is 3, 7, 2. And -3 times 1 is -3. -3 times 4 is -12. And -3 times 6 is -18. And we'll add these together. 3 plus -3 is 0. 7 plus -12 is -5. And 2 plus -18 is -16. That's what I'm going to write as my second row. And as you get more comfortable with this, you don't necessarily have to do that marginal work. But you may find that to be necessary. And I have to do that at times also, because it's very easy to make a mistake if you're trying to do this mentally. All right, so next, first column is done, 1s and 0s. Now we move to the second column, and we want the second entry in the second column to become 1. We get this to become 1 by multiplying by its multiplicative inverse. That's a -1/5. That's equivalent to dividing by -5. All right, so row 1 stays the same. 0 times -1/5 is still 0. -5 times -1/5 is 1. And -16 over -1/5 is 16/5. Now we've got the introduction of fractions. That's okay. Fractions are okay here, and you will work with fractions. That'll be a common occurrence, typically. All right, so now we have the 1, the pivot. Now we want everything else in the second column to be 0. And so we can do this by adding to row 1 the additive inverse, -4, times row 2, the row with the 1. So row 1 minus 4 times row 2 is, let's see, 1, 4, 6. -4 times row 2, 0 times -4 is 0. 1 times -4 is -4. And -4 times 16/5 is -64/5. All right, so we'll add these together. 1 plus 0 is 1. 4 plus -4 is 0. and 6 plus a negative 64 fifths. Okay, some work to do here. Let's convert 6. Let's write that as a common denominator of 5. Okay, so 6 can be written as 30 fifths. I'm just multiplying. I'm thinking of 6 as 6 over 1, and I'm multiplying top and bottom by 5. 6 times 5 is 30, so 30 over 5. Now, 30 over 5 plus a negative 64 over 5, 30 minus 64 is a negative 34, and that is fifths. So we replace top row by 1, 0, negative 34 fifths. Second row is still 1, 0, 1, 16 fifths. All right, this is row reduced echelon form, all ones and zeros. So my solution, x is equal to negative 34 fifths. Y is equal to 16 fifths. Yes, you can write that as a decimal if that makes you feel more comfortable. Be careful when you're writing decimals, because sometimes these fractions are the decimal places keep going, right? So it's better to use fractions because they're exact answers as opposed to rounding decimals. And now we're ready to work an example, this time in 3 variables. All right, so this is going to be more steps involved, right? Because we have 3 rows, 3 columns, but the steps are the exact same. All right, so we have this augmented matrix, 2, 4, 6, 22, 3, 8, 5, 27, negative 1, 1, 2, 2. Remember, this represents 3 equations with 3 variables, x, y, z. So we'll start off with the same steps. We want to get this leading term in the first column to be 1. We can do that by multiplying row 1 by the multiplicative inverse, 1/2. And we multiply everything in that first row by 1/2. So that becomes 1, 2, 3, 11. Everything else stays the same. Right, once you get the 1, you want everything else to become 0. So we want this 3 and the negative 1 to both become zeros. And I want to do this in the same step so I can save room here. All right, so what do I need to do to force this 3 to become a 0? Well, I'm going to take row 2 and I'm going to add to that the additive inverse times the column that has the 1 in it. Row 2 plus a negative 3 times row 1. And doing the same thing with that third column, that third row, I'm going to add the additive inverse to this negative 1. The additive inverse of the negative 1 is a positive 1. So plus 1 times row 1, the row with the 1 in it. Okay, so we can work over here in the margin. My first, row 2 minus 3 times row 1. That is 3, 8, 5, 27. And negative 3 times row 1 is negative 3 times negative 6 times negative 9 times negative 33. I'm adding that here. So 3 plus negative 3 is 0. 8 plus negative 6 is 2. 5 plus negative 9 is negative 4. And 27 plus negative 33 is negative 6. That is my second row. That's 0, 2, negative 4, negative 6. And then we'll do the same thing for row 3 plus 1 times row 1. That is negative 1, 1, 2, 2 plus 1, 2, 3, 11. Negative 1 plus 1 is 0. 1 plus 2 is 3. 2 plus 3 is 5. And 2 plus 11 is 13. Okay, now first column's done. We have ones and zeros. Now we move to the second column. We want the second entry of that second column to be 1. We get that second entry to become 1 by multiplying row 2 by the multiplicative inverse. Multiplicative inverse is 1/2. So 1/2 times row 2. Everything else stays the same. That'll be 0, 1, -2, and -3 when we multiply by 1/2. Okay, so we have that pivot. We have that 1, and we want everything else in that second column to be zeros. So we want that 2 and the 3 to become 0. And we are going to do that by adding the additive inverse of those numbers we're trying to make 0. So row 1 minus 2 times row 2, because row 2 has the 1 in it, and row 3 minus 3 times row 2. All right, so row 1 minus 2 times row 2. One, 2, 3, 11. And -2 times row 2, that's 0, -2, +4, +6. We'll add this. We get 1, 0, 7, 17 for row 1. Row 2 stays the same. And now for row 3, minus 3 times row 2. That would be 0, 3, 5, 13. And -3 times row 2 is 0. -3, 6, and a +9. That is 0, 0, 11, 22. And second column is done. Now we want our third column. We want this number here to be 1. We can do that by dividing by 11 or multiplying by 1 over 11, 1/11. And this will result in everything else is the same. 1, 0, 7, 17, 0, 1, -2, -3, and 0, 0, 1, 2. All right, we got one more step to go. Getting my zeros. Everything else in column 3 should be zeros. All right, and we can do that. I'll try to squeeze it in here. We want to add to row 1 the additive inverse, -7, times row 3. Row 3 because that's the row with the 1 in it. And then we'll do the same thing to row 2. We want the additive inverse of the -2, which is a +2, times row 3. All right, so R1 minus 7 times row 3. That's 1, 0, 7, 17. -7 times row 3, that would be 0, -7. Nope, 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 nope. Still 0. I'm looking at R3. 0, 0, 1, 2. So 0, 0, -7, -14. There we go. So that's 1, 0, 0, 3. Okay, and then our 2 plus 2 times row 3 is 0, 1, -2, -3, and 0, 0, 2, 4. And that's 0, 1, 0, 1. And row 3 stays the same. All right, and so now column 3 is done. We have this in reduced row form. And when we have a unique solution, you should see this diagonal of zeros, of ones, everything else 0. So that way we can say that 1x plus 0y plus 0z is equal to 3. 1y equals 1, and z equals 2.